Good morning. Today we are going to see about how to make a heap tree. Before the construction of a heap tree, we have to know what is meant by binary tree. Actually, when you just consider a tree elements which will be consisting of 4, 5, 7, 8. For these 4 elements, you have to construct a tree. That is, say, a binary tree where it consists of a root and which followed by a child. Where this root is called as a parent, and these are siblings. The parallel the below the parents are called as the child. These are called as nodes, and which will be connecting these are called as edges. So how to construct a binary tree is that where you will be taking the first element, you will be putting into a parent, then followed by a 5 with next element, and then 7 will be on the intermediate right, and then you have 8, which the binary tree consists of only 2 nodes, that is 2 childs. So there is an 8, we can't able to add it under 4, so you will be adding this 8 under 5. So actually this is called as a binary tree. Actually, when you come to heap sort, actually there are two methods of constructing heap tree. One is min heap and the other is max heap. In case of min heap, the minimum elements will be at the root. Say for this value, 4 will be the root. And when you consider a max heap for this value, the root element will be the maximum element, that is the 8 will be the root element of this tree. Okay. I will show you an example by constructing a heap tree by taking in an example of 8, 10, 5, 12, 14. Consider these 5 elements. We are going to construct a heap tree for these 5 elements. The first procedure what you will be starting is taking the first element and putting it into the root, then followed by the next element on the intermediate left side of the root, that is 10, and followed by 5, the next element on the after inserting the first element, you have to check for the root element. For construction of now we are going to construct a max heap. Let us say consider a max heap, that is a maximum element should be at the top of the root. So you just check these two values, which is higher, the 10 is higher. So for construction of max heap, the 10 should be at the root. So you are just interchanging it. So the 10 will be at the root and followed by 8 at the child level. Then you will be entering the next element. These 2 elements has been over. Then next element is 5. You will be inserting the 5 to it. Now you will be checking for the values where you can find the 5 is lesser than 10, so no problem. You can add our next element. What is the next element? It is 12. So you will be adding 12 underneath 8. What you will doing? You will be checking the values. Here that value is greater than 8, so you will be interchanging it. So what will become 10? Here it is 12. Then here it is 5. Here it is 8. Then again you will be checking with this one, the upper root of 12. Again it is lesser than. Again you will be going for a swapping. What will become a 12 become a root, then underneath it will be a 10, then followed by a 5 on the right, then and below it will be 8. You will be checking for this. It is almost max heap. It follows the max heap property. Then what is the next element? It is 14. You will be inserting 14 to the right side of 10. You will check for it. There is a violation in the property where the 14 is greater than 10 is less, so you will be swapping it. While swapping it, what will becomes 14 will go into the root. So 12 followed by the 14 on the left and 5 on the right, then 8 on the left, then 10 on the right. Then again you will be checking for this root. Here the rules fail, so you will be swapping it again. It will become 14 followed by 12 and followed by 5 and by 8, then it is 10. You will be checking for the properties. 14 is greater than 12 and 5, then 8 is lesser than 12 and 10 is less than 12. So this satisfies the heap property. So this is a max heap.